the instructions, it's okay. But I was saying that at last class, we had gone over the lion's share of chapter 1, and we had actually drifted over into chapter 2 a little bit, and this is where we left off. So we'll pick up from here today.
Okay.
So for the quiz assignment, you said you didn't understand the instructions? For decimal division, you need to figure out where the decimal point will be placed in your answer before you divide. So in this example, we're being asked to divide 14.4 by 6. So your divisor, or the number that you're dividing by, in this example is going to be 6, and it's a whole number, right? So in your answer, you need to place your decimal point directly above the decimal point in the dividend, which in this case is 14.4, okay? So as you can see, they set that up for you already. Before you start dividing, put your decimal point right above the decimal point in the dividend, okay? And then you would just proceed with the rules of division like we saw in chapter 1. So 6 goes into 14 twice. 6 times 2 is 12. So you draw your line, 14 minus 12 is 2. But we're not done, we bring down the 4. 6 into 24 is 4. 6 times 4 is 24. You draw your line, and then you subtract 24 from 24, and we have 0 remainder until we have our answer. 6 into 14.4 is 2.4. And you can see that because you placed your decimal point here in advance, you're simply just proceeding with the rules of long division as we've learned in chapter 1. And if it helps you when you're dividing, multiplication and division, you can think of them as cousins or closely related cousins, okay? So the moment you get the answer for your partial division, so by partial division, I mean you've asked yourself how many times is 6 going to 14, you've decided that it's 2. So that's your partial division because you're not complete, right? You're not done with the complete division, right? So when you get your answer for your partial division, always remember that immediately you need to say hi to its cousin, multiplication. You need to multiply, right? So we said 6 goes into 14 twice, right? And immediately we're going to multiply. 6 times 2 equals 12, right? And then you're going to subtract because basically you're telling yourself, okay, 6 goes into 14 twice. We have 12, but there's our division is not complete. So what portion of our dividend, which is this number right here, do we still need to divide? Well, to decide that, you need to subtract what you've just found from your original number to figure out what you have left to divide, right? So 14 minus 12 is 2. We bring down the 4, and this is what we have left to divide. 6 into 24 goes 4 times. And again, we say hi to the cousin. 6 times 4 is 24, right? And then again, we're asking ourselves, what do we have left to divide? Well, we know the answer is 0, because 24 minus 24 is 0, okay? So that's just a way for you to kind of pace yourself as you're working through these, through long division. Know that when you get your answer for your first partial division, you're going to multiply immediately, okay? And then once you've multiplied, you need to subtract to figure out what you have left to divide, and then bring down whatever's left. Again, how many times does your divisor go into whatever you have left? Write down your answer, multiply immediately, subtract to see what you have left. In this case, we have 0, okay? And then you know that you're complete. You've completed the steps. So once again, that's just a good little, I guess, mental map for you to keep in mind as you're working through these, so that you're not skipping any steps in between as you're dividing. If your divisor, which in this case is 0.35, happens to have a decimal point, you need to move the decimal point in both the divisor and the dividend before you can start your division as normal. So in this case, we see that 4.9 only has one place after the decimal point, but 0.35 has two places, right? You always want to start with your divisor because that's going to be king. That's going to be value or the decimal number that determines how many decimal places that you need to show in your answer. Okay, so first start by writing 0.35, okay, and then count the number of decimal places that you would need to move to the right to make 0.35 a whole number, right? So in this case, you would need to move 1, 2, and when we get to the second decimal place, we have 35, okay? So that immediately tells you that you need to do the same thing to your dividend and you need to move exactly 2 places over to the right, okay? So because 4.9 only has one decimal place after the decimal point, just add a 0. Let's see. If you had, let's say this read 4.9495, for example, okay, you would still move only exactly 2 decimal places to the right. Why? Because there's only 2 decimal places in your divisor, and your divisor is king. Your divisor always determines how many decimal places you're going to move, okay? So before you continue with your long division, you want to put your decimal point right above the decimal point in your dividend so that you know that when your answer is complete, you don't have to worry about it. You know that it's in the right place. You know that it's where it's supposed to be. Okay. And then we're just going to continue with long division as normal. You're going to ask yourself, how many times does 35 go into 4? The answer is 0. 35 doesn't go into 4, right? So we move over to the next place. How many times does 35 go into 49? The answer is 1, okay? And immediately we do what? We multiply. 35 times 1 is 35, okay? And then you're going to subtract to figure out how much left you still need to divide, right? So 49 minus 35 is 14. But we're not done because we need to bring out, we need to bring down the 0, right? 35 goes into 144 times, okay? And what do we do next? We multiply. 35 times 4 is 140. And then we need to figure out, well, how much do we have left to divide? And we find that out by just subtracting 140 from 140. Our answer is 0. We're done, okay? And we already know where our decimal point is, so you can just simply write your answer as 14. If you like, you can add a 0 to reflect the decimal point. But as we discussed a few lessons ago, 14.0 or 14 and 14 essentially the same number, right? But do pay attention to what the what the question is asking you. So if the question asks you to report your answer to 1 decimal place and you complete and you see that your answer is a whole number 14, you would need to indicate the 1 decimal place with a 0, right? If your answer asks you, if the question asks you to report your answer to 2 decimal places, well, you would just write 14.00, right? Like you would see on a receipt, for example. If your answer asks you to report to 3 decimal places, of course, you would add 3 zeros on and on, okay? So just pay attention to that. If the question is asking you to report your answer to a specified number of decimal places and you happen to get a whole number, just know that you can add 0 to reflect those decimal places that your question is asking for, okay? Um, so in terms of fraction basics, the book touches on some key ideas that you need to keep in mind. The bottom part of a fraction is going to tell you how many parts um, the object has, or the group of the group, or the group of objects have. Okay, and then the top number gives you information about how many parts of a group you're working with. So when you see a top heavy fraction, meaning that the top of the fraction is bigger or is greater than the bottom of the fraction, it simply means that that fraction is greater than one. Because the number, or the denominator, which is the value on the bottom, always tells you how many parts of a whole that you have. So if you see, let's say, I'm not, just for the sake of this example, I'm not going to give a number for the numerator, so for the number in the top, but you see something over 3, that tells you that the whole, think of the whole as a circle, is divided into 3 parts, right? If you happen to see 5 over 3, that lets you know that there's in the numerator a circle that's been divided into 3 parts, that's our whole, with 2 left over, right? So that's indicative that your top heavy fraction is greater than 1, in the sense that 5 is greater than the number of parts in your object, which in the example I'm trying to give is 3. Okay. So just really quickly, when you see a top heavy fraction, 5 over 3, 10 over 2, things like that, just know that the author is trying to tell you that that fraction that you're looking at is greater than 1, meaning 1 whole part. Okay. So if a fraction uses 2 numbers, a fraction uses 2 numbers to represent a whole number. So the bottom of a fraction is called the denominator, as we've discussed several times, and it tells you how many equal parts are in the whole group, or in the whole object, or in the item, or however you want to visualize that, okay? The top of a fraction is called the numerator, and the numerator tells you how many parts that you're working with. So how many parts of that whole that you're working with, okay? So in this particular illustration, we see a rectangle with 4 equal parts, okay? And of those 4 parts, we see that 3 are shaded in gray. And so another way of saying this is that 3 out of the 4 parts that we're working with are shaded in gray, okay? You could also, I guess, you could also express this as 1/4 of the rectangle is not shaded in gray, okay? So when the numerator is smaller than the denominator, you have a proper fraction. A proper fraction always represents a quantity less than 1. So remember, when you see a top-heavy fraction, it means that fraction is greater than 1. If you see a proper fraction, meaning that the numerator is smaller than the denominator, you have a proper fraction, and it means that it's representing a quantity that's less than 1. An improper fraction, as I mentioned earlier, is a top-heavy fraction. So if you see mention of improper, know that it's the same, or it has the same meaning as a top-heavy fraction. And again, an improper fraction means that the top is greater than the bottom, and that the quantity being represented is greater than 1. So in this rectangle, we see 6 equal parts that are shaded in gray. So we have 6/6, which equals 1. Just letting you know, so this 1 here is representing the entire rectangle, is shaded in, is letting you know, excuse me, that the entire rectangle is shaded in gray. So for the pair of circles that we're looking at, each circle is divided into 2 equal parts. And a total of 3 of the parts are shaded. So 3, 1, 2, 3 over 2. So 2 here representing the whole. So we have 2 whole circles. 3 parts of the 2 whole circles are shaded in gray. Okay, and that's essentially what this fraction, this top heavy or this improper fraction is telling you, that we have, again, 3 parts, 1, 2, 3, of 2 whole circles. They're shaded in gray. So usually when you see a top heavy fraction, you may be required to express it as a mixed number. And a mixed number is simply a fraction that has one whole number and a proper fraction. Because we're going from an improper fraction, which is 3/2, to a mixed number, and the mixed number would be expressed as one whole number and then a proper fraction, because we're reducing this this improper fraction to its lowest term, right? By expressing it as a mixed fraction. So, well, the fraction in the mixed number is going to be in its lowest term, okay? So essentially you can rewrite 3/2 by dividing 3 into 2, 1, and you have 1 left over. It's 3 times 2, excuse me, 2 times 1 is 2, and 3 minus 2 is 1, so you would have 1 left over, and then 2 being your denominator, you would just simply write down 2, and here's your mixed fraction, 1 and 1/2. Okay, and if it helps, you can visualize this improper fraction, because essentially we're just saying that we have one whole circle that's shaded in gray, and then we have another circle with only half of it shaded in gray. Okay, and so that's why these two fractions are reflecting or representing the same quantity. They're just written in different ways. Okay, so I guess a key point to remember here is that anytime you see a top heavy fraction, you can reduce it to a mixed number, and that mixed number is equal to your top heavy fraction in the sense that they're expressing the same quantity, but in different ways. Okay. Do you want me to repeat anything here, Jaleesa?
No, you're fine.
Okay. So yeah, if you have trouble visualizing fractions in a problem, it helps to just quickly draw a sketch. And the first thing you want to look at is your denominator. Your denominator is going to tell you how many parts to divide your sketch into. So if you see whatever over 3, draw a circle, divide it into 3 parts, and go from there. If you see whatever over 10, draw your circle, divide it into 10 parts. Your denominator will always tell you how many parts to divide your object, your circle or your rectangle, whatever you choose to draw into. All right.
Yeah, I get it. Okay, I'm
Okay.
ready.
Okay, good. I'm glad you're getting it. Okay, so you can change an improper fraction to a whole number or mixed number, as we've just discussed. So to change a top-heavy fraction or an improper fraction to a mixed number, you simply divide, right? So you ask yourself, how many times does 5 go into 16? Well, the answer is 3, because 5 times 3 is 15. So you would write down your 3, and then you would ask yourself, well, okay, now we've divided 5 into 16 3 times. Do we still have a quantity left over in that numerator? And the answer is yes. What we have left over is 1, and we decided that by simply subtracting 15, which is the number of times that 5 goes into 16. We subtract 15 from 16, and 16 minus 15 is 1. And that tells you that when you divide 5 into 16 3 times, you'll get 3 equal parts, or 3 circles shaded in, with 1 circle left over that only has 1 part shaded in. Okay. Trying to see. And then, so if you wanted to express this 3 remainder 1 as a mixed number, you would simply write 3 and 1/5, right? Because this is telling you that you have 3 circles. All 3 are divided into 5. Remember, 5 is king, right? All 3 are divided into 5, and all 3 have the 5 parts shaded in. And then we have 1 circle with only 1 part shaded in gray, and 4 parts are not shaded in, right? Or we can represent that as 1/5, right? So we have 1 circle where only 1 part of the 5 are shaded in gray. So you can either write your answer this way, it's 3 remainder 1, or you can write it as 3 and 1/5. Okay, so pay attention to what the question is asking you, or how the question is asking you to represent your answer. Okay. Oh, and this is essentially what we just discussed, that we divided 5 into 5, is 5 into 16. Our answer was 3. We had found that we had 1 left over of our whole with 5 parts in it. Okay, 3 and 1/5. Okay, so here we're being asked to go in the other direction, right? We're being asked to change a mixed number, 7 2/3, to an improper fraction. So essentially, you're gonna multiply 3 by 7, which gives you 21. Then 21 plus 2 is 23. And that 23 is greater than 3. So you know that you're done with that process. You now have your top heavy, or your improper fraction, 23/3. So again, you want to start by multiplying 3 by 7, which gives you 21. Then you're going to add 21 to 2, your numerator, and that's going to give you 23. And you're just going to write 23 over your denominator, which in this case is 3. And so what are we telling ourselves here with this number? We're saying that we have 7 circles, and all 7 circles are divided into 3 parts, right? And all 7 circles have all 3 parts grayed out, except for 1 circle, which only has 2 parts grayed out. Okay, and then the improper expression of that is you simply just adding the number of grayed out circles, which is 23. You can think about it that way, right? If we go back to our illustration here, remember how we were discussing that these two circles can be represented in two different ways, right? You can count the number of grayed out parts, which is 3 in this case, over the number of circles, which is 2, or you can represent them in terms of the whole quantity. So here we have one whole circle that's grayed out, and then we have one circle that only has half grayed out, and that's what this represents here. And essentially these two quantities are the mathematician's way of representing the same thing. So instead of expending all that energy explaining what's going on with the circles, the mathematicians have figured out a short way of letting you know what's going on. Either 3/2 or 1 and 1/2, and they represent the same quantity that we're looking at. And that's essentially going to apply to any mixed fraction that you're working with, okay? So like the tip that we saw earlier was telling you, if you're having trouble, you can draw 7 circles, divide each circle into 3 parts, gray them out, whatever you need to do to help you understand what's going on here, okay? Okay, so to perform operations with fractions, you need to be able to write equal fractions in higher or lower terms. So the terms are the numerator and the denominator. Top of your fraction, bottom of your fraction, numerator, denominator. And then a fraction is reduced to its lowest terms when its two terms, the numerator and the denominator, do not have any common factor except 1. So again, when you see lowest terms, you know immediately that we're talking about a fraction with the numerator, that's your first term, and the denominator, that's your second term. So we have 2 terms, and you're being asked to, if you're being asked to express a fraction in its lowest terms, they're simply just saying, rewrite that fraction so that the numerator is as small as possible and the denominator is as small as possible, okay? In the other direction, you may be asked to raise a fraction. And if you're asked to raise a fraction, you always want to make sure that you're multiplying by exactly the same number. So in this case, the goal was to raise this fraction by 3. So if you multiply the numerator by 3, make sure that you multiply the denominator by 3. And the reason the reason what you want to do that is because you always want to make sure that your fraction is still expressing the same quantity or the same number, or you can think of it as the same number of grayed out circles, right? So let's say you had 3, a circle with 4 parts, only 3 of it are grayed out. And then you need to distribute that circle to 3 different people, right? You need to give that circle to 3 different people, and you're being asked at the end of the day, how many circles do you have that are grayed out once each person has a circle? Well, your total number of grayed out circles will be 9, and you can reduce this 9 over 12 to 3/4 to just represent that one circle that you started with that only had 3 parts of it grayed out. Okay, so essentially, remember when we talked about multiplication, we discussed it as a concept in terms of multiplying the same number several times, right? So instead of adding 2 + 2 + 2, 2 + 2 + 2, you can just multiply 2 times 3. And so the same thing is happening here. We're multiplying 3 by 3 and 4 by 3, we get 9/12. But essentially, when you reduce this 9/12 into its lowest terms, it gives you 3/4, which is which is the quantity that you're multiplying several times. Okay, and in this case, 3/4 is that quantity that we're multiplying 3 times. Okay, so I guess the key thing to remember or to keep in mind is that when you're raising a fraction, you're doing so in such a way that when you reduce the end quantity, it should always reflect the original number. Okay, so when you reduce this by 3, 3 goes into 9 3 times, 3 goes into 12 4 times, you're back at your original number. Okay, and so that's why it's important to always raise the numerator by the same number as the denominator, so that your your number, in the event that you need to return it to its original form, will always reflect the same number that you started with. Okay. So here we're being asked to reduce 10/15. We know that 5 goes into 10 twice, and 5 goes into 15 3 times. So our final number is 2/3. And if we wanted to return 2/3 to its original condition, we would multiply 2 by 5 and 3 by 5. 2 times 5 is 10, and 3 times 5 is 15. Okay, so I guess the goal to keep in mind here, or what you need to remember here, is that it's important for you to learn the multiplication table, as we saw, I think it was in chapter 1, so that when you're working on these fractions, you can recognize, okay, am I raising by the correct number to ensure that in case I need to return to my original value, I've raised by the number that will help me do that? Or am I dividing by the correct number in case I need to return to my original value? Okay. So the key here is, again, recognizing multiples, and you will, I guess the best way to be able to do that is to learn the multiplication table. All right, so in lesson 4, the main ideas that this portion of the chapter, or I guess, tries to convey is how you add and subtract fractions. So you can add or subtract fractions, but they have to have the same denominator. If the denominators are not the same, then you need to find a common denominator and then raise one or both of the fractions. And then you always want to reduce your answers to the lowest terms and change improper fractions to mixed numbers. And again, all of this terminology you're now comfortable with and you now understand, because we've gone over them at length. But it's good to always I would have like a little dictionary type thing that you make for yourself, where you write down the term and its definition, so that as you're working, if for whatever reason you've forgotten, you can just quickly look, okay, improper means top heavy, means the top fraction is greater than the bottom. Okay, back to the question. Denominator means the quantity on the bottom of my fraction. Okay, back to my question. Okay, so I suggest like making yourself a dictionary that defines these terms, or the terminology that you see quite often, and then also your operations that, like we discussed in the last class, like if you see combine, sum, that they're asking you to add, things like that. So make yourself like a dictionary that you can work with so you can get more comfortable with the terminology that's being used. So you can add or subtract like fractions. Like fractions are fractions that have the same denominator. So they have a common denominator. So if you see like 2/5 and then 3/5, they're like fractions because they have a common denominator, and that common denominator is 5. So in this example, we're being asked to add 3/10 plus 5/10. And this is pretty straightforward. You simply just add across. 3 plus 5 is 8. And remember, your denominator stays the same. Your denominator is 10. And the denominator stays the same. Why? Because the denominator is a representation of the number of parts that you're working with, right? So since we're working with 10 parts, we want to reflect that in our answer, okay? And these are like fractions, so the denominator stays the same. We have 3 plus 5, 8 parts that are graded, over 10 parts total. And you should recognize that 8 and 10 have a common multiple, and that is 2. So you can divide 2 into 8, and you would get 4. And then 2 into 10, you would get 5. And now you've reduced this fraction into its lowest term, which is 4/5. And in the event that you want to return to your original number, maybe to check your answer or to make sure that your lowest term is not an incorrect answer, what would you do? You would just multiply 4 times 2 is 8. 5 times 2 is 10. So that lets you know that your lowest term here is not incorrect, because when you multiply it by their shared multiple, which is 2, you get your original value, which was your original fraction, I should say, which was 8/10. Okay, so that's another way to check your answer. So if, for example, you had done all this work and you ended up with 3/5, and then you wanted to check your answer and you multiply 3 by 2, you would get 6. 5 times 2 is 10. So you know that you've made a mistake somewhere, maybe in writing down your numerator on this side, for example, because you shouldn't be getting 6, you should be getting 8, right? So that's a good way to check yourself. Once you've divided your answer into its lowest term, by finding their shared multiple, which in this case is 2, you can multiply your answer by that multiple, the same multiple, to see if it takes you back to your original answer. Okay. Here we're being asked to subtract 2/9 from 2/9 from 7/9. And you should recognize immediately that 2 is less than 7. So you need to rewrite this so that your the difference you're taking begins with 7/9, which is the larger fraction. Okay, so you would rewrite this as 7/9 minus 2/9. And again, we're working with like fractions, right? Because they have the same denominator. So you would write down 9 and then just simply subtract 7 from 2, and that answer is 5. Okay, and you can think of this in terms, again, of our circle. We've got a circle with 7 parts shaded in. And then the author's asking you, what would you have left over if you took, if you changed those 7 gray circles, if you changed 2 of them to white? for example, okay? Or if you erased them so that if you erased two grayed out circles, how many grayed out circles will you have of that circle that has 9 parts? Well, your answer is 5, right? Because 7 minus 2 is 5. Okay. So again, as the tip that we saw earlier suggested, it's always good to try to visualize the fractions because it helps you with understanding what it is that you're doing, essentially. Okay. Okay, and then this is telling you that if the denominators are not the same, you want to raise them to using the same multiple, so that then you could have like fractions, because you can only subtract or add when the denominators are the same. So this is just telling you to remember to make sure to change in the event that you had a denominator that was different from one of your other fractions, you want to make sure that you change that denominator to reflect the same quantity in the denominator, in this case 9, and then you can continue with the subtraction. So if your solution to a fraction, a fraction problem is not one of the answers that you've been given, one of the answer choices, make sure that you reduced your answer to its lowest terms. And this is kind of similar to the tip that that was given to you about decimal operations. Because if you remember, we discussed that decimals and fractions are two ways of reflecting the same quantity. So for example, 1/2 equals 0.5. And the tip concerning decimals was if you see answers that are a few decimal places off from what you found, then know that maybe you need to round your answers either up or down to closely match the number or the choices that you've been given. Okay. And this tip is essentially telling you more or less the same thing that or expressing the same concept, I should say. Make sure that you have reduced your answer to its lowest terms so that it can actually match your answer choices. Because you may actually have the right answer, but it's not reduced to its lowest terms, right? For example, like if you had 2/10 and you're seeing 1/5, 2/10, they're 2/10 and 1/5 are reflecting the same quantity, if you want to think of it in terms of those circles that we saw earlier. But at face value, it might look different because you haven't reduced 2/10 to its lowest term, which is actually 1/5. Okay. So that's what this is telling you to keep in mind, that you may have worked through your problem and you actually have the right answer, but because but it may look different from your multiple choice answers because you haven't reduced the answer that you found to its lowest terms. So here we're being asked to add 5/6 and 1/4. And immediately we recognize that the denominator in both fractions are different. So one way to find a common denominator is to think of the multiples of both denominators, right? So you can just start by writing down the multiples of 6, which is 6 itself. So anytime you're writing down multiples, the number you're working with is always a multiple of itself, meaning that you can divide 6 into 6 and you would get one equal part. So basically a multiple is just, one way of thinking of a multiple is how many times can you divide the number in question into its multiple, because its multiple will not have anything left over. Okay, so 6 can be divided into itself once with nothing left over. So you always want to start with the particular number that you're looking at as a multiple of itself, and then continue as needed, right? So 6 is a multiple of itself. The next multiple is 12 because 6 plus 6 is 12. And then the next multiple is 18, or 6 plus 6 plus 6 is 18, or 6 times 3 is 18. You can also think of this as 6 times 2, which is 12, right? So 6 plus 6, or 6 times 2, then 6 plus 6 plus 6, or 6 times 3, right? So essentially, we're just multiplying this number by 1, 2, 3, 4. The next multiple here would be 24 because 6 times 4 is 24. 5, the next multiple would be 30 because 6 times 5 is 30. And so that's all a multiple means, is you're taking a number and you're going down the multiplication table. For example, 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24, 6 times 5, 30, 6 times 6, 36, so on and so forth, right? But here we're trying to find the lowest multiple. So start with the first 3 numbers if you want to, all right? Then move to 4, right? You want to start always with itself. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and then you go, aha, we have a shared multiple here, which is 12, because you could continue. 4 times 5 is 20, 4 times 6 is 24. They do, both numbers do share a multiple of 24, but 24 is not the lowest, right? You always want to choose the lowest common multiple, okay? And in this case, for both numbers, that lowest common multiple is 12. So then you need to ask yourself, well, what did we do with 6 to get 12? And what did we do with 4 to get 12? Well, to get 12, when we're dealing with 6, we multiplied by 2. So that means we need to multiply 5 by 2 as well. Remember what we said earlier, whatever you do to the numerator, you have to do to the denominator. So since we multiplied 6 by 2 to get 12, we're going to multiply 5 by 2, and that gives us 10. So we have 10 over 12 as our first fraction. Remember, the goal is to turn this into like fractions so we can add, right? And so we started by trying to find the lowest common multiple, and we decided that that was 12. Okay, and then we asked ourselves, well, how did we get 12 with 6? We multiplied it by 2. And so since we multiplied 6 by 2 to get 12, we're going to multiply 5 by 2. Okay, and then that gives us 10 over 2, which you see here. And then again, ask yourself the same question with 1 over 4. What did we do to get 12? Well, we multiplied 4 by 3, right? 4 times 1, 4, 4 times 2, 8, 4 times 3, 12. Remember? So because we multiply the denominator by 3 to get 12, we're going to multiply the numerator by 3 to case that gives you 3 over 12. And now you can add your fractions. So 10 over 12, which we got from multiplying 5 over 6 by 2. 5 times 2, 10, 6 times 2, 12, 10 over 12 plus 3 over 12, which we got by multiplying 1 times 3 equals 3, and 4 times 3, which equals 12. And now we can add because we have a like fraction. So you write down your denominator, which is 12. Then 10 plus 3 is 13. And then you want to reduce, because this is a top-heavy fraction, right? The 13 is greater than 12. So you want to reduce this top-heavy fraction to a mixed number. 12 goes into 13 one time, and then you have 1 left over because 13 minus 1 is, excuse me, 13 minus 12 is 1, okay? And your denominator is the same, 12 across the board, okay? If it helps you, I think that you can write down the steps of what you need to do when you're adding or subtracting fractions that don't have the same denominator. Because remember, when you're looking at when you're given two fractions and they both have the same denominator, it's easy because you can just add across straight away, like we did here, to get your answer, right? But when the fractions don't have the same denominator, there are several steps that you need to work through so that you end up with with like fractions that you can easily add. Okay, and the first step is to find the lowest common multiple, okay, which in this case was 12. And then you want to separate your fractions. And then once you have your like fraction or the same denominator, you can go ahead and add and then reduce if you need to the lowest terms. Okay. I'm gonna stop and see if you're okay. Don't be afraid to ask questions, please. If you want me to repeat anything, or if you are not feeling comfortable, just let me know. So here we're being asked to subtract 4 and 1/16 from 1 and 3/8. So what you want to do is raise the second fraction so that it has the same denominator as 16. 8 times 2 gives you 16. So that means that you need to multiply 3 by 2 as well. And that would give you 6. So now we have 6/16. And then you want to reduce, because the numerator in our mixed number 4 and 1/16, the numerator in this mixed number is smaller than the numerator for this mixed number. So we're going to borrow a 1 from 4. And when we do that, we rewrite our fraction as 3 and 16/16 plus 1 and 1 over 16. Okay, which gives us 3 and 17/16. And now we can go ahead and subtract 3 and 17/16 from 1 and 6/16. And our answer is 2, which we get from subtracting 3 from 1. 2 and 11/16, and 11 comes from subtracting. It's not necessary to find a common denominator to multiply and divide fractions. To multiply fractions, you simply multiply the numerators and then the denominators, and then you would reduce your answer if necessary. So in this particular example, we're being asked to find the product of 7/8 and 1/2. So 7, we simply just multiply across. 7 times 1 is 7. 8 times 2 is 16. And we have our answer 7/16. This is the lowest term. It can't be reduced any further. And so we have our answer 7/8. times 1/2 is 7/16. So here we're being asked to find 1/3 of 3 3/4. So all you would need to do is change 3 3/4 to an improper fraction. And then you'd multiply across. So 3 times 3 is, excuse me, 3 times 4 is 12, plus 3 is 15. So that's your improper fraction right there, 15/4. And then you simply just multiply the numerators and the denominators. So 15 times 1 is 15, 4 times 3 is 12. And then you want to change this top heavy or improper fraction to a mixed number. So 12 goes into 15 once. 15 minus 12 is 3 over 12, which is your denominator. And you recognize immediately that this can be reduced further. So you divide 3 into itself, and that is 1. 3 divided by 3 is 1. Divide 3 into 12, and that gives you 4. And 1 1/4 is your mixed number in its lowest terms. So we now have our answer. 1/3 of 3 3/4 is 1 1/4. So you can use a shortcut called canceling to reduce fractions as you work through your problem. So to cancel, you would simply just divide both the numerator and the denominator by the same number. The numerator and the denominator can be in different fractions. So here we're being asked to multiply 7. Excuse me, in example 7, we're being asked to multiply 1 1/2 by 1 1/5, right? And so you want to start by changing your mixed fractions into improper fractions. So 1 1/2 changes to 3/2, and we get that by multiplying 2 by 1, which gives you 2, and then adding 1, the numerator, excuse me. So 1 1/2 is equal to 3/2. And then multiply 5 by 1, which gives you 5, plus 1 is 6. So 6/5 is your improper fraction for this quantity, 1 1/5. And then you want to set up your multiplication problem. So both 6 in the numerator right here, and 2 in the denominator for this fraction are evenly divisible by 2. So you would divide across. And you want to remember with multiplication, you divide across, because if you divided if you divided from bottom to top, you would go back to the original quantity that you had, right? So this would give you 1 1/2, which is what we don't want, right? We're going forwards, not backwards. So you divide across. 2 into 2, 1, 2 into 6, 3, and then you multiply your numerators and your denominators. 3 times 3 is 9. 1 times 5 is 5. And then you would reduce 9/5 to its lowest terms. 5 goes into 9 one time. 9 minus 5 is 4. And then your numerator is 5. And so your answer is 1 4/5. So you'll need 2 additional steps to divide fractions. Before dividing, you want to invert the divisor, or the fraction that you're dividing by. And to invert the fraction, you simply want to switch the numerator and the denominator. So just flip it on its head. And then finally, you change the division symbol to multiplication, multiplication symbol, and then you just simply multiply. excuse me. So in this example, we're being told that Jim has an 8-pound bag of nuts that he wants to fill using smaller half-pound bags. And we're asked to find out how many small half-pound bags he can make from his 8-pound bag. Okay. And simply you want to divide 8 by 1/2. So you want to set up your division problem by just writing 8 divided by your fraction, which is 1/2. You would change your whole number to a fraction by just simply putting 1 underneath as your denominator. And then to divide by 1/2, you need to flip the divisor, which is 1/2, on its head. And so now we're working with 8/1 times 2/1. Because remember, once you flipped your divisor, you want to change your division sign to a multiplication sign. So 8/1 times 2/1 gives you 16/1, or 16. And so we now have our answer. If Jim wants to fit his 8-pound bag of nuts into smaller half-pound bags, he can do so 16 times. So when you multiply a fraction, when you multiply by a fraction that's less than 1, your answer should always be smaller than the number you started with, because you're multiplying or you're finding a part of a quantity. So let's say the easiest example would be multiplying 1/2 or 0.5 by 1. Your answer would be 0.5. And that answer is smaller than the number you started with, which is 1, because you're multiplying by a part, or you're finding a part of 1, which is your whole number. You're basically 1/2 of 1 is 1. It's the expression is saying find part of 1 by multiplying it by 1/2. And so your answer should always be smaller than your part, your whole number, which is 1. Okay. And then when you're dividing by a fraction that's less than 1, the answer should always be greater than the number. So for example, if you're asked to divide 0.25 by 2, your answer is 8. And 8 is greater than the number 2. And it makes sense. So you can think of it like, let's say you have $2 and you're being asked to give 25 cents away. How many people will get 25 cents from that $2? Well, the answer is 8, right? And that's what all this is telling you here, is that when you're dividing by a fraction or a decimal, that's less than that's less than 1, your answer should be greater than the number. So in our case, 0.25 or 1/4 is less than 1. So our answer, which is 8, is greater than 2, the dividend. Okay. To change a fraction to a decimal, you simply need to divide the numerator by the denominator. To change a decimal number into a fraction, you want to write out the number without the decimal point, as we saw earlier in one of the examples. In other words, you want to write out the number as a whole number, and then you want to count the number of places in the decimal point. And then the whole number, count the number of places in the decimal point, in the decimal number, and then repeat that for your dividend. and then put your decimal place right above the decimal point in your dividend. And then you can go ahead and uh, divide as normal, as you would with whole numbers. Fractions and decimals are two different ways, but feel free to stop me at any point. Fractions and decimals are two different ways to depict a part or a proportion of a whole. So even though, excuse me, fractions and decimals are written in different forms, they are conceptually equivalent. So because they can be, they're conceptually equivalent because they can be used interchangeably to represent the same portion of a whole number. So for example, 1/2 or 1/2 is the fractional representation for half of a whole, and the decimal equivalent of 1/2 is 0.5, right? And so you would see this if you were to apply the long division approach to finding a 1 divided by 2, you would get 0.5. In this example, we're being asked to change the fraction 3/8 to a decimal point. 3/8 just simply means 3/8. You would just enter 3 divided by 8 into your calculator, and you would get your answer. You can also change a decimal to a fraction by first writing down the decimal number over the place value name of the last digit to the right of your decimal. So for instance, in this example, excuse me, we're being asked to change 0.35 to a fraction. So you want to start by writing down the decimal number over the place value name so that the place value name, which in this case is hundredths, since 5 is in the hundredths column. So you want to write down 0.35 as a whole number, 35, and then place 35 over its place value name, which, as we just discussed, is the hundredths place. So you would place 35 over 100, and then you would proceed with reduction until your fraction is in its lowest terms. In this case, the lowest common multiple between 35 and 100 is 5. So you divide 35 by 5, you get 7. 100 divided by 5 is 20. So you'll find it, here's a helpful chart showing you decimals and their fractional equivalencies. So lots of useful ones for you to memorize. For example, the fractional equivalent of 0.1 is 1/10. The equivalent of 0.5 is 1/2. Yeah, so these are a lot of the fractional equivalent of 0.3 is 3/10. The book suggests that you memorize this chart, and I think it's a really good suggestion, essentially, because these are common fractions and their decimal equivalents that you are likely to see quite often, more often than not. And so these equivalencies become useful, especially when you're working with percentages. So take some time to get to know these. And I should mention quickly, when you see a bar over a digit like we see here for the decimal equivalent of 1/3, which is 0.333, this bar is simply letting you know that the author decided to stop at the 1,000th place, but this 3 continues into perpetuity. And this bar is just a representation of that this 3, this number, this 0.333 continues this decimal number, I should say, continues, the 3 repeats itself into perpetuity. And so the author decided to stop at the thousandths place. If you saw the bar at maybe the tenths place, for example, it's essentially the same thing. 0.3 repeat, with 3 repeating into perpetuity, but the author decided to stop in the tenths place, in the tenths position. Yeah, and so that's essentially what this slide is saying, that the decimal equivalents for 1/3 and 2/3 are marked with a bar, and the bar just essentially indicates that the decimal repeats indefinitely. So you want to look at the answer choices before you begin working on multiple choice problems, because that would help you know whether or not you need to you need to write down your answer either as a fraction or as a decimal. And this is kind of, again, as I mentioned, I think it was in the first lesson of chapter 2, no, the second lesson. Earlier in our discussions, I mentioned that when you're working on word problems, try to avoid looking at the answer, because sometimes word problems contain superfluous information, and the answers that match that information that you need, is superfluous information, is sometimes in your multiple choice. And so you want to avoid looking at the answer. Try to work through the problem, come up with your answer on your own, and then compare what you found with the choices, so that you're not tricked by an answer that was found using superfluous information, right? In this case, this tip makes sense because you want to, and this, when you're working in the decimal or fraction, or when you're working with decimals or fractions, you want to make sure that you're presenting your answer in the correct form, right? So if the answer, excuse me, if the question is asking you to present your answer as a decimal, and you found a fraction, let's say 1/2, well, its decimal equivalent is 0.5, and the question is asking you to present your answer as a decimal. So if you presented your answer as 1/2, it's technically incorrect, because 1/2 is not a decimal, right? It's a fraction. So this is just telling you to pay attention to the form of your answer. And you can get a hint from looking at how your answers are presented. So don't look to match or don't look to figure out the answer ahead of time, but do look to see how your answer is presented, so that you know the expectation in terms of how you should write down whatever it is that you find. Okay. You can use fractions and their decimal equivalents to save time when you're working on your test. So for example, in this particular scenario, we're told that each dose of cough medicine contains about 0.25 ounces of medication. And then we're asked to figure out how many ounces of medication are in 48 doses. And you would simply just convert 0.25 to its fractional equivalent, which is 1/4. And then just go ahead and multiply 48 by 1/4. 48 times, or you can write 48, which is a whole number in its fractional form, as 48/1. So 48 times 1 is 48, and then 1, which would be the denominator for your whole number 48. 1 times 4 is 4. You now have your top heavy fraction, that you can reduce further. 4 goes into 4 one time, 4 goes into 48 12 times. And now we have our answer. We can, if we have a bottle of medication that has 48 doses and we take 25 ounces each time, we can do so 12 times. So knowing fraction decimal equivalents can also help you interpret remainders when you're working with your calculator. So for example, Ray inspects machine assemblies, and he must inspect 12 assemblies during his 40-hour work week. Excuse me. On average, how many hours can he spend on each inspection? Well, it's pretty easy, right? All we need to do is enter 40 divided by 12 into our calculator. The right side would display your answer, which is 3.333 into perpetuity. That 0.333, since you know that 0.333 with a bar on top is indicative of 1/3, you could just write your answer as 3 1/3. 3 1/3 hours. All right, so we discussed a number line as a picture that kind of helps you compare the sizes of numbers. So numbers on the left are smaller than numbers on the right, and your number line can also be used to represent and compare decimals. Fractions and mixed fractions can also be represented on a number line. So on the reasoning test, the reasoning portion of the GED, you may need to recognize or locate fractions and mixed fractions or even decimals on a number line. So a number line represents numbers in order from least to greatest. So as you move to the left along a number line, the number decreases in value. So if our starting point is 5 and we move to the left, we see that it's decreasing in value. 4, 3, 2, 1, 0, -1, and so on and so forth into perpetuity. And as you move to the right of the number line, you would see that the numbers are increasing in value. So if 0 is our starting point and we're moving to the right, 1, 2, 3, 4, 5. And that the arrows in the end just mean that the line continues into perpetuity on both sides. Oh yeah, this is what I just mentioned, that the arrows on the end of the line indicate that the line continues forever in both directions. Excuse me. So if you imagine zooming in on a portion of the number line, it would look something like this. So if we zoomed in between 0 and 2, we would see something like this. And you would see sort of 1 partitioned into smaller striations or to smaller divisions. So 0.25, 0.5, 0.75, 1. And then moving on to the right, 1.25, 1.5, 1.75, 2, and on, right? So a number line can include decimals and whole numbers. For example, we see here that this point, or this dark point that you can see here represents 0.75, which is greater than 0.5, and which is less than 1. Okay, our whole number. And as we mentioned earlier, a number line can also represent fractions and even mixed fractions in increasing order. So here, starting from 0, we see 1/4, 1/2, 3/4, and then 1. And then to the right of that, 1 1/4, 1 1/2, 1 3/4 if you wanted to continue, 2, and so on and so forth. So the questions on the mathematical reasoning test may ask you to recognize a fraction or a decimal on the number line, or they may ask you to place a dot on a line to represent a fraction or a decimal value. So you could draw yourself something like this, and then divide your line accordingly, and then show where the dot or should be placed according to whatever is being asked in the question. So in this example, we're told that John works 5 shifts per week, and his boss asks him to spend exactly half of his time this week working on a specific project. And the question is asking you, how many work shifts will John devote to that project? And you're asked to circle your answer on the number line below. Well, you simply need to multiply 5, the number of days that he works, or exactly 5 shifts per week, or so the number of shifts that he works, by 1/2, the amount of time that he expects to spend, right? So 5 times 1/2, if you can imagine our multiplication across, you would write 5 as in its fractional form, which would be 5/1 times 1/2, and then you would just multiply across. 5 times 1 is 5, 1 times 2 is 2, you would have 5/2. And then if you were to reduce 5/2 or if you were to rewrite 5/2 as a mixed fraction, 2 goes into 5 2 times. 2 times 2 is 4. So 2 goes into 5 2 times. That's your 2 right here. 2 times 2 is 4. 5 minus 4 is 1, which you see reflected over here in the numerator. And then your denominator is 2. And so that's your answer. John will spend exactly 2.5 shifts on the project, or he'll need to work 2.5 shifts to complete the project. So lesson 7 kind of walks you through calculator skills that you'll need when you're working on the reasoning portion of your exam. So there are several important keys that are used to work with decimals and fractions. Fraction and decimal operations are entered in the same order as whole number operations. So the same way that you would work whole number operations. On your TI 30 XS multi-view calculator, you want to use the decimal point key, which will look exactly like this. For it, you'll see a decimal point on one of the raised keys, and you want to use that for decimals, and then you want to use the fraction key. You'll see this notation on one of the raised keys for fractions. So to work with mixed functions, you would use the second function, and then you would press the fraction key to access this notational operation that you need to use for mixed fractions. So when I say raised keys, I mean keys that actually have a button that you can press. And for the keys that don't have a button that you can press, you need to use the second function. So you need to press second function first and then access the operation using the raised key. So in this case, if we wanted to work with mixed fractions, we would press second function, and then we would press the fraction key, which is a raised key, and that would then give us access to the what do you call it? The mixed fraction operation. So the second function is essentially you just telling the calculator, no, I don't want to use the raised key. I want to use the second function above the raised key. So each raised key will have right above it a second function written uh, in tiny form, or like, I don't know, tiny font, I should say, right above it. And to access the second function, you would press the second function key and then proceed with your calculations. So this is the second function key that I was referencing. Right here are your cursor keys. So you want to move, let's say you're working with fractions and you want to get to the numerator, you would press the top or the up arrow to help you move your cursor, and then you would enter the relevant value for your numerator and so on. This key right here is your fraction key, and it's used to enter fractions. So this is the same key that you would use if you want to enter a mixed fraction. You would press your second function key, as we discussed earlier, and then you would press your fraction key, and that would give you access to the mixed fraction key, which is right above, it's written in tiny font, right above the right above the fraction key. This toggle key here helps you toggle or change between fractions and their decimal equivalents, and it will help you change between a fraction and its decimal equivalent, or between a decimal and its fractional equivalent. So it helps you toggle back and forth between the two right here. And then this is your decimal point key that we made reference to earlier. It's difficult to see, but it's right below the input for 2, for the value 2, which is here, your digital input for 2. You'll see your decimal point key right below that. So a fractional answer can appear in the form of an improper fraction, and in order to change to an equivalent mixed number, you can use the second function over this key right here. This is an exponential key, and right above it you would see the second function to help you toggle from an improper fraction to its mixed fractional equivalent. Okay. So this is essentially just showing you how to work with your calculator when you're working with decimals. So to solve 3.89 plus 2.5, you would simply just use your digit keys to enter 3, and then right above, or excuse me, right below the number 2, you would see your decimal point, enter that, then press 8 and 9, your relevant operation, which in this case is the plus symbol. So your operation keys are right here on the right-hand side. Yes, enter the relevant operation, enter the number 2, press your decimal point key, enter the number 5, and then press enter. And once you press your enter key, you'll see your solution on the right-hand side of your display. Same with 5.2 minus 0.78. You just press 5, press your decimal point key, press 2, your operational key, which in this case is subtraction, enter 0.78, and your answer will appear on the right-hand side. And again, these are pretty just straightforward. It's just a matter of you matching whatever values you see with your input keys, and then press enter. So you'll see several calculator functions to work with fractions and mixed fraction operations. So you want to first start by practicing how to enter fractions and converting them to the decimals. In this example, we're being asked to reduce 56 over 448 to its lowest terms, and then convert it to a decimal. So the first thing you want to do is clear your calculator. As we've discussed already, your TI calculators are programmable, so they store information in their memory. So even if you're just turning on the calculator for the first time, you always want to start by clearing the calculator to make sure that you're removing anything, any calculations, any prior calculations that may be stored in the calculator's memory. And then you want to proceed with working on your problem. So here, since we're working on a fraction, you would press the fraction key to enter your fraction. And once you press the fraction key, the cursor will start flashing on the numerator. So you just simply enter 56 where the cursor is blinking. And then you want to use the cursor keys, which are right here. You want to use the cursor key. So you would start by pressing the fraction button, which is right here. And then you would see that the cursor is blinking on the side. You would enter 56, and then you would use the cursor key to press the down arrow right here. And then you would enter 448. And then you simply press enter to reduce that, and automatically the calculator knows that you're trying to find the lowest term, because you didn't enter an operation key after that. So you didn't enter, like, you didn't press addition, you didn't press multiplication, division, subtraction. So it knows that you're looking for the lowest term of this fraction. And it gives you that in the display on the right-hand side, which is 1/8. And then to express the fraction as a decimal, you would press the toggle button to toggle between a fraction and its decimal equivalent. And so the decimal answer would appear on the right-hand side of the screen. And this is the toggle key that you would press. So once you've pressed your fraction key, you've put in your entries, you put in your numerator and your denominator, you press enter to get your fraction in its lowest form. You press this toggle key, and you would find your fractional equivalent displaying on the right-hand side right here. All right, so now in terms of mixed fractions, as I said earlier, you would need to use the second function key. And this example walks us through how to use that. So here we're being told that a plastic pipe is to be cut into pieces measuring 1 7/8 inch. The original pipe is 20 feet and 5/8 of an inch long. How many pieces can you cut from the pipe? Well, you simply need to divide 20 and 5/8 by 1 7/8, right? So you start again by clearing your display, you're clearing the memory of your calculator. Excuse me. And then you need to recognize that since you're working with mixed fractions, you need to press the second function key, okay? And then press the fraction key, because the mixed fraction operation is right above the fraction key. So we press the second function key, then the fraction key to take us into the mixed operation zone. And then once we're in your mixed operation formula will display on the left-hand side of your screen. Then you're going to just move across your formula, your mixed fraction formula, using your cursor keys. So your cursor will be blinking next to the whole number key. So you want to start by entering 20, or next to the whole number variable, I should say, not whole number key. So enter 20 and then press the right arrow to navigate to the numerator. Then enter the number 5, then press the down arrow to navigate to the denominator, press the number 8, then press the right arrow to move to the right side of your input so that you can enter your required operation, which in this case is division. So you press your division key, press the second function key again, and then the fraction key to access the mixed fraction operation. And then you would see again your cursor blinking next to the whole number portion of your formula entry. You would enter 1, which is our next, which is the next value for our second mixed fraction. Then you press the right arrow so that you can access your numerator, enter the number 7, press the down arrow so that you can access your denominator, enter the number 8, then press the right arrow to indicate that you're done with all your entries, and also just so that you don't enter another number accidentally, and then press enter. And your answer would display on the right-hand side of your, or your answer will show on the right-hand side of your display. And in this case, the answer is 11, 20, and 5/8 divided by 1 7/8. The answer is 11. And so we can say that this pipe, the original pipe, which is 20 and 5/8 feet long, 20 feet and 5/8 inches long, can be cut 11 ways if the dimension that we're measuring is 1 7/8, 1 foot and 7/8 of an inch. That's about it for chapter 2, and we covered chapter 1 the last class. So or we reviewed chapter 1 on Tuesday. So that's essentially it for today's lesson.